All right. Pardon me? Just turn the kettle on. All right. So, we're going to go through this. I'm going to put out the answers. Now, listen to me. Every question, every answer is worth 1 mark. Okay? If you don't get the answer, but you have some of the work right, you give yourself a half for that particular mark. Okay? Everybody with me? Now, if I write down an answer, and my explanation that I write up here makes no sense to you, and you have a different answer, what is your job? To ask. When? Immediately. Not Tuesday before the test. Understand? If you do not ask, whose problem is it? Yours, because I am not telepathic, because telepathy sucks. Okay? All right. Some of them I'm not going to do any work for, because some of them are easy. I can do them in my head. Okay? So if I do that, and you have a different answer than me, you can ask. All right? All right. I'm feeling orange today. 71,500. That is too thick. 71,500 centiliters.
Is that only 1 word?
Yes. So you only had to do one thing. Now, this question, you guys would say, oh, Mr. Myers, I don't have milligrams to ounces. But if you look on the back, I went over it at least twice with various groups. You do have grams to ounces, and you know how to move milligrams to grams. Milligrams to grams moves 3 steps, so that is 0.413 grams. Now you need ounces. 1 ounce is what you want, is 28.35 grams. So you have 0.413 divided by 28.35 to get 0.0149. Some of you will have 0.15. Some of you will take that 0.15 and round it to 0.02, which of course you should not do. But anything like that gets you your point. Any questions? It's going once. Going twice. Going thrice. Okay, good. 6.14 kilometers is 3.81 miles. If you left it at 0.81, take your full mark. I'm fine. If you went further, that's fine too. What would you, I lie, wrong word. What could you break miles down into? Yards, or you might use feet, right? Or you might do yards and feet. Okay, but if you have at least 3.81, I'm happy. If you did yards, it's like 3 miles and something like 4,700 yards. Something like that. I don't remember exactly. Right? So if you have anything like that, you're getting your full mark. Centimeters to yards. Mr. Myers, centimeters to yards isn't on our data booklet. No, but meters to yards is. So you take this and you turn it to 5.93 meters. You want yards, so that is times 1 yard is 0.9144 meters. So it's 5.93 divided by 0.9144, which gives you 6.49, which I'm perfectly happy for you to round up to 6.5 yards, which I am perfectly happy to have you say is 6 yards, 1 foot, 6 inches. Any of that gets you the mark. Any questions there? Sweet. 2.3 yards to millimeters, it's the exact same thing. You don't have yards to millimeters, but you have yards to meters, which gets you 2.103 meters, but you need millimeters, so you move the decimal 3 places. It might be 2,105, I can't remember, but if you think that I'm going to argue with you over 2 millimeters, then you don't know me very well. Any questions? Once, twice, thrice. Lovely. What? Taco Bell? Why Taco Bell? What does Taco Bell have to do with once, twice, thrice? Does something to do with thrice and Taco Bell happen? What?
I thought we were just saying random things.
Oh, but thrice isn't a random word. Thrice means 3 times, like twice means 2 times. There is no 4 one, so don't ask. No, it's not Feist. Feist is a wonderful Canadian singer, but Feist is nothing. Unless it means something in your crazy kid slang that I don't know, which it might. Ounces to milligrams, you don't know, but you know ounces to grams, and you change that to milligrams. 35 ounces. You want grams, so it's while we wait, and we wait longer, we wait still longer, we wait still longer, we are still waiting due to quality technology. I wish,
Why not? They'll replace it.
because somebody has to pay for it.
Just say a student raged and threw a window. Then one of us would get blamed for it.
Then one of you would get blamed for it.
What if he doesn't know? What if he came back to his class and bam?
35 times 28.35 gets you 992.5 grams. But you don't want grams, you want milligrams. How long are you going to be sitting back there if you can't shut up when I'm talking? Oh, give me an estimate. No, you do. You're a smart guy. Not very long. That's a good estimate. Very well done. That's understanding the room and understanding what's going on. Now apply that to math class. Good. You hear what I said there?
Yeah.
You think that applied to you too?
Yeah.
Good. It's got to move, huh?
Isn't it 0.25?
Okay. I didn't have a calculator. Now that's got to move 3 spaces. So it is 992,250 milligrams. 385 feet, inches to feet, divide by 12, that gets me 32.08 feet left over. 0.08 feet times 12, because feet to inches is 1. 3.05 tons. This is a problem, and this one you have to pay attention to, because the guys that invented the metric system decided that the biggest measurement in metric was ton, T-O-N-N-E, because they were French. The Americans and the people that used imperial measurement had a measurement that was ton, T-O-N. They're different. They have the same name, they are different. A ton, the French one, is 2,200 pounds, or 1,000 kilograms. A ton, like Murica, is 2,000 pounds, which is stupid, but we know everything about imperial measurement is stupid. So that is going to be times 2,000, which is 6,100. Choose a color.
Purple.
There is no purple.
Green.
There's teal and green.
Teal, yeah.
Teal.
Well, we already did teal.
Yes, we did.
What's the last time haven't we done?
I don't think we've done green.
List of the colors.
Okay, do the green.
We haven't done green.
Yes, the green.
Honey crisp apple or green passion fruit? No, again, this is the way we do these
Passion
things.
fruit.
Triangle.
Right. Left.
Passion fruit.
Left.
Right.
My right or your left?
Your left.
My left?
You're right.
My right. Honey crisp apple.
Yay. I got the timer.
Timer man.
Yeah.
3 to 5 minutes. 3 minutes, please.
Hold up, I have to reset that in second before.
Yes.
Okay. Ready?
Can you what, huh? Of course you can. As always, anytime you people need to leave class, it is always fine. But, as always, you are making that choice. If you miss out on something, like a review before a test, you're still writing the test. 3 minutes? Excellent. So this was 6,100. And this you divided by 16 to get 6 pounds, and you were left over with 13 ounces. That part's out of 9. Anybody want to ask about any of them? Going once. Going twice. Going thrice. Excellent. Last question. Photocopying is bad, so I will accept a range of answers here. All right, the actual answer is right there, which is 4 and 11/16. But I will accept anything from 5/8 up to 3/4, which is, of course, 10/16 to 12/16. But you would never say either of those measurements. You would round it off, right? You would simplify, right? Over here goes to right there. So that is 8 and 5/8, but I will accept 9/16 to 11/16. Any of them would get you the full mark. Any questions about that one? Good. What's the trick in 26 that I put in to mess with your head? Yeah, he's got to paint it 3 times, right? So once you find the surface area, what did you have to do? Multiply by 3. Did you find the surface area of the ceiling? No, of course not. Did you find the surface area of the floor? No, of course not. You found the surface area of the 2 walls and then multiplied by 2, right? So the walls were 4 by 3 and 3 by 3, which is 12, and 9, which is 21, which you multiplied by 2. You had to 42 square meters, which you multiplied by 3 to get 126 meters squared, which you then divided by 12 to get 10.5. How many liters of paint must I buy, Eric? 11. What if it worked out to 10.1? You still need 11, because if you only buy 10 liters of paint, you're going to leave a little corner somewhere. Personally, if it were me, I'd leave it in the middle of the room and hang a picture over it, but that's just me. I wouldn't go back to Home Depot to get enough paint to cover that much. But some people might. That page is out of 9, 10, 11, 12. Give yourself a mark out of 12. Now, when you turn the page over, there's 2 blanks. It's worth 2. Okay? Now, these questions are, there's more than one way to do all of them. So let's say I start showing you how to do a question that is totally different than what you did. Chill till the end, because the answer might work out. Okay? All right. I always do surface area first because surface area is harder. So the surface area of this thing, there's 2 ways to do it. You could say, well, Mr. Myers, that is a rectangular prism, right? 2 WH, HL, LW. Yeah? Except, what part of it's missing? That rectangle. So I would have to subtract 8 times 20 from my final answer, yes? That would cover the green part. Agreed? Then you would go ahead and do the top part. It's a triangular prism. There is no formula for triangle prisms, so you must add up all the sides. There's that roof part. How many of them? Times 2. And there is that roof part. Times 2. Except you... But they also cost a buttload of money. These don't work, but they got them cheap. So, where was I? Oh, yes. That triangle made a square, didn't it?
Yes.
So if you found 6 by 6, you found that was 36, right? So you ended up doing the bottom and doing the two roofs, and when you add it all up, you got...
500.
Maybe. I don't remember.
That's what I got 444.
I know it's not 444 because I would have remembered that.
Oh, what did you get? 670. What I got you 270.
600. My battery's running low. No kidding. The doy. All right, so it was 8 by 4, it's 32, plus 20 by 4 is 80, plus 20 by 8 is 160, which is 240, and 32 is 272, times 2 is 544, but I got a minus 8 times 20, which is 160, minus 160, which is 444, minus another 60 is 384 on the bottom. And then the top was 6 by 20, which is 120 times 2, which is 240. So 384 plus 240 plus 36 is 390, and 30 is 420, 660.
I got 6 something. I screwed it up.
So, look at what you did. Figure out where you went wrong. If you don't have 660 and you did some of that work, you're getting a half mark. Volume is, of course, easier. So I do volume secondly. And, of course, there's two ways you could have done volume. You could have found the volume of this guy because he's a normal everyday prism, right? And then you could have found the volume of this guy, which is half of a normal everyday prism, right? So if you did LWH for blue and then divided by 2 and then added those numbers, you would have been fine. Agreed? Okay. The other thing you could have done, and this is what I do with these because it's less work. I recognize that that shape repeats, doesn't it? All the way to the back. So that makes that the base and that the height. So if I find that area, which I know is 6 by 6 divided by 2, which is 18, and 8 by 4, which is 32, I know that that yellow is 50, and it needs to multiply by the height, which is 20, which gives me a surface or a volume of 1,000. Whatever you did, you should have come out to 1,000.
Somewhere around 1,000? Somewhere around 1,000?
No, 1,000. You should have had exactly 1,000.
1,000 centimeters.
Yes, of course. But I am not too fussed about those.
Are you serious?
Now, next one. Again, does that have a formula? No, because it's not a single shape. So a great many of you could have found this whole surface area and then this whole surface area and then subtracted overlaps. You could have added up all of the sides. That would have worked too. Or you could have recognized, like I showed you in the practice for this, isn't this just that prism with some of it cut out? What part is cut out? That rectangle right there. How many parts, how many times is it missing? Twice. So if I know that green part, which is 9 by 2, it's 18, and it's missing twice, I'm going to be losing 36, yes? So if I go ahead and I do the surface area of this as a proper prism, 2 times 8 by 18 plus 8 by 4 plus 4 by 18, and then I minus that 36, I will have the answer. And I think, if I'm not mistaken, it's 461, 60, 462, or 460. It's just 460, okay? And then volume, again, you could have found this volume, then this volume, and added them together, or you could have recognized that this shape repeats, doesn't it? It repeats 8 in height. So if you know this surface area times the height, you have the volume. You know this surface area is 18 by 4 minus 18, right? 18 by 4 is 720 minus 18 is 62, 54. So 54 times 8. 8 times 50 is 400. 8 times 4 is 32, so 432. Now, why did I spend so long talking about all your options here? Because they are your options. One requires you to do a bunch of little calculations and add them all up. Yes? The other way requires you to know a concept and be very comfortable with it, but do a much less work. Who makes the decision? You do. Whatever works for you. What if you have a method that is totally different than what I did either way, and you still got the right answer? Do I care? No, because this is not elementary school. Do whatever you need to do to find the right answer. Okay? Excellent. Easy one, just surface area, 2 pi r squared plus 2 pi r h. If you write it out, you can't do it wrong. 2 pi 5 squared plus 2 pi 5 15. 5 squared, 25 times 2, 50 pi. 2 times 5 is 10. 10 times 15, 150 pi. 50 pies and another 150 pies are 200 pi. If you got there, you get the full mark. If you can't leave it like that because it makes you crazy, it's 628 blah. I don't care. Any questions? Excellent. Bonus problem. Not for marks, so it didn't matter. But I would like to talk about it because it uses a mathematical, not even a mathematical problem, a logic problem, not even a problem, a logic tool that all of you need for the rest of your math career. Okay? So, first of all, did anybody try this that didn't try it yesterday? Did anybody try it at home? Did you try it at home or did you Google it at home?
I tried it.
You tried it. Do you have an answer for me? It's okay. No. Remember I said that that was a typo.
Okay.
You're trying to find how much the water will rise. I don't know how that surface area got there.
I got that it would raise 37.625% more.
37% more, which would be not quite right, but okay. Corey.
I found that it would rise by 360 centimeters cubed because the triangle prism was much smaller than the cylinder, and it would be completely submerged.
Well, I got that too.
Okay, you're absolutely right, Corey, except how tall are you?
I actually don't know because it's been forever.
No, just say it in feet. You're 6'3", you're 6'4", who cares?
It's been forever since I got married, so I don't even know.
Okay, let's say you're 6'4". Are you 6'5" feet squared or feet cubed?
No.
Do we measure height in squares or cubes?
Oh.
What is height measured in? One dimension, right? So yes, you're absolutely right. It's going to go up by 300 centimeters cubed because that's how big the prism is. Anybody else got an answer? Christian. It's going to rise by 22.2%. 22.8%, which would be No, not quite, but I like where you're thinking. I like people that have gone the percentage route. That just means you've made a mistake in your calculation, because the percentage route works too. Now, when I show you how to do this, I'm going to show you how to do this using the formulas that we already have, okay? Because that's the math lesson I want to teach you here. Everybody cool? All right. So first of all, let's start with just make sure we're all on the same page here. There's my water, yes? Okay. What shape is the water? It's whatever shape its container is. So what shape is the container? Cylinder. So the water is a cylinder, yes? So the volume of the water is the same as the volume of a cylinder, yes? Which is pi r squared h. Agreed? Okay. R was what from the question? 8 squared, then pi, and h was what from the question? No. The cylinder is 50. The water
25.
is 25. Is everybody cool? 8 squared is 64. 64 times 25 is 1,600 pi. Is everybody good? Now, a lot of you don't like that, right? You want the number there. You find that makes your algebra easier. I don't care. I can do that for you. Whichever one you want. It is approximately 5,026 or something. I can't remember exactly.
5,026.55.
Great. 5,026 will be close enough, right? Okay.
I got the water volume also.
Okay. Is everybody cool with what I did? Now, according to the question, I took this triangular prism and I dropped it in there, yes? Which means volume is the amount of space, right? So right now there's 1,600 pi centimeters cubed in there, yes? When I drop that in, that volume is going to be added to there, right? That volume is 360. How do I know it's 360? Base area of 20, height of 18. Base area times height is the volume of every prism, yes? So this is 360, agreed? So how much am I adding to this? 360. Which means I get 5,386.55. Does everyone agree? Everybody follows my thinking there, yes? So this red number is the volume of the water plus the prism, yes? Okay. Now, once the prism is in there, what shape is that water? Still a cylinder, yes? What's the formula for volume of a cylinder? Pi r squared h, agreed? So right now, the volume of the prism and the volume of the water we know is 5,386.55, yes? But it's also a cylinder, right? So isn't the volume of the water plus the prism also pi r squared h? It is, isn't it? So if the volume equals that, and the volume equals that, then what do I know about the red and the black? They're the same. So isn't 5,386.55 equal pi, but not r? What's r? It's radius, which we have already. The radius was 8. So this is 64 pi, right? Because 8 squared. Do I know the new height? That's what I'm trying to find. So there's an h. Do you know how to solve that? Got to move stuff. It's just algebra, right? What math is happening to 64 and pi? Times. So what math do I do to get rid of them? So if I divide this side by 64 pi, what do I get? Here's where calculator skills come in. What do I have to remember when I put that into my calculator? Where, Ash? Around the 64 pi. And what do you get for an answer? Absolutely right, 26.79. So now we know the water started at what level? 25. The water ended up at what level? How far did it rise? 1.79 centimeters. The point of the whole question was that, which is not circling because of the piece of garbage. That is the point of the whole question. If you have anything in math ever where the same thing equals two different things, then those two things are equal. Does everybody understand? Now, will you get a question that hard on your test? Of course not. Why? Exactly. Practice harder than you're going to play the game. Right? Because if you practice harder than the game, then the game's easy. If you work harder than you need to do for your tests, how easy are the tests going to be? Right. Now, all the people that left that totally blank, because a great many of you did, was it necessary to leave it totally blank? Were you really unable to fathom any part of that question? The water was in a cylinder. You know what volume is. You know that the prism has volume. You know that when you drop something in water, the water goes up. Everybody could have done something there, right? Would you leave it blank on a test? Good. Because never, ever will I give you a question that you know nothing about. Okay? If I was that type of person, then I would be telling you to answer these questions in Greek. But I'm not. Turn the page over for the last two. They're easy peasy, lemon squeezy. A cone. Boom. Boom. There's a cone. Now, a kid in the other class said, doesn't it have to be drawn the other way? So the curve is touching the circle? Does it? It's the same shape. So then I had some fun. I highlighted it and I rotated it around for him. And okay. It doesn't matter. But the question is, I want the surface area of that cone. What's the formula for surface area of a cone? Pi r squared plus pi rs. Do I have all those things? Yeah. So you just fill it in. Pi times 18 squared plus pi times 18 times 30. And you get 324 pi plus 400. No. 540 pi. And you get 864 pi, which is something around 2,700. Now, listen please. Listen please. What if you didn't have slant and I said you had a height of 30? What would you have to do if I wanted surface area? I'd have to do Pythagoras with what numbers? 18 and 30, right? What if I gave you the slant height, but I wanted the volume? What would you have to do? You'd have to do Pythagoras again the other way because you would need the height because you had the slant. Everybody cool?
Wait, you just subtract reverse of.
Yes, you start with the hypotenuse and subtract instead of starting with the legs. Now, it's ironic that we bring this up at the very end of this because guess what the first lesson of trig is? Pythagoras. It's almost like I planned it. All right.
It's trigonometry.
Huh?
It's trigonometry.
Trigonometry?
Yeah.
Oh. Dad joke Thursday. Dad joke Thursdays.
Doing dad joke Friday now.
Volume 4 pi r cubed divided by 3, which is 4 pi times 28 cubed divided by 3, which is something like 91,925 or some crap like that. Have a good weekend.
Bye.
Surface area is 4 pi r squared. 4 pi times 28 squared. something around 900 times 4. It's about 3,500 pi, which is something like 12,000, but I can't remember. Okay, why?
Because I got two completely different answers.
Okay, why? Are you familiar with the formulas?
Yeah, I did the exact same thing.
Okay, so you did 4 times 28 cubed,
Yeah.
right? 28 cubed is a gigantic number.
Oh, I put a 2, so actually I think that was supposed to be 3.
Okay,
I remember.
okay. It's a gigantic number. It's like 91,000. It's 28 times 28 times 28.
Yeah.
28 times 28 is almost 900. Times 28 again is 280,000. Times 4, right? It's a big number. If you filled it in and you got to here, you can have full marks. Even if you wrote a 2 instead of a 3 there, because I'm going to believe that you did write a 3, because I believe that you can read a formula. And I don't care if you screw up with your calculator. This one's out of 2, because there's 2 blanks. So now that gives you a total score out of 20. So you will go back to the front. You'll give yourself a score out of 20. When will you tell me that score?
On the test.
Does the bonus one help?
Nope. You will tell me that score on the test. What else? What other score will you tell me on the test? Your quiz out of 11. Right? I'll remind you of that today. I'll remind you of that on Monday. I'll remind you of that on Tuesday before I hand the test out. And some of you still won't do it. But that's okay. Everybody good? All right. Shake your sillies out. Talk to your neighbor. Get a drink. You have 2 minutes before we start reviewing Pythagoras to move on to trig. Go. One of my favorite characters and one of my favorite movies. Okay. Geek check. What's the font?
Use Comic Sans.
Back to the Future.
No. But you're on the right track. Star Wars.
I had that.
The theorem Pythagorean, must you know.
Hey, you should use Comic Sans.
No, Comic Sans sucks.
Oh, Comic Sans is just the best.
I don't know what page number it is in yours. I think it's 44-ish or 48.
Mr. Myers, don't you think it's the best font ever?
No, Comic Sans sucks, and you know that I feel that because you wouldn't have brought it up if you didn't. So you obviously have been talking to somebody from my class, one of my previous classes, where they know my opinion of Comic Sans. Now, there's a reason I spend any amount of time on Pythagoras. First of all, it's one of the most important and real-life used piece of math in all of the world. Not just in Western culture or Eastern culture or any other culture. Everyone uses this. Why did we name it after an old white guy? Because that's what we did. Everybody had this figured out in the whole world, but the old white Greek guy is the guy that wrote it down. Okay? It's very important. The problem with it is you are all taught it this way. Correct? Every single one of you has seen that a million times. And that's wonderful if you take an extra 1 second to actually learn what it means. And the vast majority of you don't. Because if I said this triangle was CAB, and I told you that this was 6, and this was 4, and this was 3, you would do Pythagoras, and you would tell me that C would equal 5, and you would hand it in to me. I've taught math for 20 years, Ash. I've given a million questions of Pythagoras with the ABCs in the wrong spot. And 999,999 times it comes back wrong. Because you guys learn a formula. You don't learn what it actually means. Which is why I spent so long, couple of days ago folding up paper and discussing every formula, right? So I don't like to teach a squared, b squared, c squared. I like to teach it a different way, and we're going to do that in a second. But first, we need to make sure we are aware of the terms. What is the hypotenuse? I get a few answers all the time. One person always says, it's the diagonal line. Okay, so that means the hypotenuse is one of these two, correct? Because those are the diagonal lines. So it's not diagonal.
It's the one opposite of the 90 degrees.
Damn it! You screwed me over. You're supposed to say it's the longest side.
Oh, yes.
Say it's the longest side.
That's the longest side.
How do you know?
Oh, that's...
You didn't measure it. But now really, what is it? It's the side opposite the right angle, yes? All of you should know that. But I'm going to write this out because it is such an important piece of terminology. The hypotenuse is opposite. Now, the word opposite in math means across. So wherever the right angle is, when you go across, that's the hypotenuse, no matter what. No matter how it's drawn, no matter how it looks, no matter how it's twisted, no matter how it's turned, that symbol for a right angle points to the hypotenuse. Is everybody with me? We are not going to be using the word across to describe going across a shape. We are going to be using the word opposite. Opposite the right angle. Which is the right angle? The angle that has that symbol. If it doesn't have that symbol, is it 90 degrees? No. What if it looks 90 degrees? It's not. Okay? Okay. The legs are the other two sides. The legs, and I shouldn't have used purple because it's going to cover up legs. The legs are the sides adjacent. And I'm not going to highlight that in purple because that's going to make it hard to read. Adjacent to the right angle. If opposite means across, what does adjacent mean? Right, beside. And sooner or later that will show up. Okay? Remember, a squared, b squared, c squared doesn't actually mean those letters. It means this. Leg 1 squared plus leg 2 squared equals hypotenuse squared. That way, no matter what letter I use, no matter what symbol I use, you can always do it and do it right. Okay? All right. Do those two. It should take literally 5 seconds each. But if it takes longer, don't feel bad. It's okay. Why did I stop at 289 and 80? Why didn't I square root it? That's exactly what I'm asking. Why did I stop there? How many of you were able to get to 289 and 80 in your heads? Be honest. How many of you had to use a calculator to get to 289 and 80? Be honest. Should be every hand, right? The reason I didn't square root it yet is because a great many of you, on a test, when you're under pressure, and you've done a whole bunch of calculating already, a great many of you are going to forget that last square root. and you're going to tell me it's 289. Because when you look at your calculator, you're going to see the number 289, aren't you? Right? This is what I talk about using your common sense. When you've done a page of work, make sure the answer makes sense. If I walked 15 steps that way and 8 steps that way, would it make any sense that I was 289 steps away from where I started? No, but every year I put a question on Pythagoras on the final exam in the open-ended section, and every year 5 to 10 kids tell me that exact thing. I give them a map, I say this place is this far from this place, blah, 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 and they tell me that the lake that is 3 kilometers this way and 8 kilometers this way is somehow 71 kilometers across. And they hand it in to me on their final exam. That's why I'm making a big deal out of it now. Of course, the final answer at the end, you remember to square root. And you get 17 and about 8.9. Everybody cool?
But if would you round it up?
Just leave it. Right? 1 or 2 decimal places, I don't care. Everybody cool? Now, Ash, if the question was ending right here and you rounded it to 9, I would be okay with that. What if we need that number later on in the same question? Should you round it? No, because you're going to round it later on. Now, next question. Everybody, you can work with a partner. I don't care. You can work by yourself. Tell me how big X is. Go. And if you finish A, tell me how big X is in B. Go. All that stuff I just said, real important. You can't do these without the extra angles. Don't be fooled into Pythagoras, using Pythagoras when you can't. Okay?
So Myers forgot to record.
I know that. That's why
I'm telling everyone on YouTube.
But everybody knows. Everybody knows. Some turkey and some mistletoe. All right. I know it's not Christmas, but, you know, that's the song. I know I can't sing. That's like telling me, hey, Myers, you're short. Hey, Myers, your hair's going gray. Hey, Myers, you're stunningly gorgeous. Those are all things I already know. You don't need to tell me stuff I already know about myself. I know I can't sing.
That last one, though.
Oh, whatever. All right. What do you notice? Because you need to be aware of what this stuff so we can talk about trigonometry. This is the stuff you need to know. What do you notice about the 3 things I have highlighted? Anything about them? They're all letters. Excellent. Anything else? They're on the corners. Excellent. Anything else? Anything else about those 3 things that I've highlighted? They're all capitals. Perfect. You got all 3 things. Yay. Give yourselves a round of applause. Yes, you did. You're on fire today. Be careful there, Ayla. You may get burned. Don't spit when you talk because it'll go tss when it hits her. All right. Excellent. Okay. So, what do we know about this? 1. Corners, which have a proper name in geometry. Does anybody know what it is? Starts with a V. Ends with an X. Has Erte in the middle of it. Vertex. Corners are vertices. Vertices is the plural of vertex. Okay? Vertices are labeled with caps. And polygons, which is a $5 word for shape, polygons are named by the vertices. Okay? So what is the name that you would give to this triangle? Seamus wants to call it ABC. Is that okay? Excellent. There are 2 other names I could give it. What are they? CAB, BCA. Everybody cool? Okay, but we have settled on ABC. Everybody cool? Great. Now, knowing what you know, name this triangle. No.
Oh.
FED. Why?
Because it's following the same one as up there.
E is down here. Sorry, it got cut off. What did Seamus notice? That he followed the same order. Right? He went from the little angle along the longer side to B up here, A to B, so he had to go F to E. And then E to D. Is everybody cool with that? Is everybody comfortable with the corners, the vertices? When I use the word vertex and vertices, I mean the corners. Ash.
You always just start in the left hand corner.
No, you can start in whatever corner you want, but you got to follow the same order for that whole question if there's more than one triangle. Or more than one any kind of shape. Okay? Everybody cool? All right, now, that covers half of a triangle, yes? Triangles are shapes that have what? 3 angles and 3 sides. Have we covered the angles? So now we got to talk about the sides. Back in the day when you were first learning geometry, you would have named this side AC or CA, correct? Right? You would have named it one of those two, agreed? Okay. In grade 10, we don't do that anymore. In grade 10, sides are labeled with the, sorry, I was getting ahead of myself. I put with and the together. With the lowercase letter of the opposite. What does opposite mean? Across. Of the opposite vertex. So, what vertex is opposite to this blue side right here? A. So what name do we give this side? What kind of A? Lil A. Everybody cool? My computer's frozen. I know. Lil A. Oh, I got it in highlighter, even though I've clearly clicked on the red. You guys name the other 5 sides there. Go, while I make my computer do what it's supposed to do. Lil A. Lil B. Lil C. Lil F. Lil D. Lil E. Is everybody cool? Everybody understand? Because it's really hard to do trig unless you understand how we name triangles and sides. Is everybody good? Seamus.
If you had multiple at the bottom triangle, you'd have the feds.
Ah, yes, you would have the feds. Then we'd be on the run. Everybody cool? All right, now, we have 12 minutes left. We're going to do one more thing, and then you're going to be off for the weekend. But you got to work with me here. What do you think would happen if we measured this angle and this angle with a protractor? What would we find? They're the same. And what would we find if we measured that and that? Same. And that and that? Same. Excellent. Okay, good. You all know that already. Good, good, good. That means half the stuff on the next page we don't have to fill out. The rest of the stuff we are going to do some math with. But in the interest of time, and to save you from having to do homework, I want you all to turn to your next page, and I'm going to give you some numbers, okay? You'll notice on the next page that there's a chart that has side length of ABC and side length of DEF, yes? We're going to put some numbers in there. The side length of A is 3.3. Please write that in. The side length of B is 5.3. Please write that in. and the side length of C is 6.4. Does everybody have those three numbers?
Yeah.
Excellent. I'm going to wait a second to make sure everybody has them. It was 3.3, 5.3, and 6.4, I believe. Yes? Excellent. Now we're going to do the same thing for D, E, and F. D is 10.1. E is 8.3. And F is 5.1. So, what were they again? A was 3.3, B was 5.3, and C 6.4. D 10.1, E, pardon? 8.3, and F 5.1. Now, this, what you're about to see, some of you already know it, but I'm going to show you anyway. This is why trigonometry works. This is why architecture works. This is why you can take a picture of a guy standing beside a tree and tell how tall the tree is. This is why you can take a picture of a guy surfing a wave and tell how tall the wave is. This is a very powerful piece of math. Take the length of side A, which is 3.3, and divide it by the length of side F, which is 5.1. Using your calculator, tell me what you get. Ooh, big party. What do you get? 647, so 0.65, yeah? Okay. Now, why did I put A and F together? Look back at the drawing. Don't flip your page back. Why did I put A and F together? They're in the same position, right? Okay. So now, when we do B, we do 5.3 divided by 8.3, and what do we get? 0.638, which is 0.64, yes? And the last one, 6.4 and 10.1, and what do we get? 0.63. What would you say if I told you that those measurements were, as you well know, were done by me with a ruler on a computer screen? Are they exact as they could be? No. So, knowing that they could be slightly more exact, look at how close the answers are. If, yes, 1/100th off. If I could measure exactly, what would all those three numbers be? Exactly the same. Which would tell us, if I had a line, oh, don't freeze, it really ruins my... If I had a line on a piece of paper, like that line up there on a blueprint, and I needed to build that line up there in real life, I can do it. Because that distance, A, compared to this distance, F, will always make 0.65, or whatever it would be. Do you understand? That fraction, then if I compared this line, B, to this line, E, B over E would give me the same number. Now, just like we just discussed, if that equals that and that equals that, what do you know about these fractions? If that equals 0.65 and that equals 0.65, what do you know about these fractions? They're the same. So you know A over F would equal B over E, which would equal C over D. That's why trigonometry works. That's why architecture works. That's why you can take a picture of a skid mark from a car crash and work out how fast the car was going. This is how you do it. Grade 10 math works in that many places in real life. In grade 10 math, we do this artificially with triangles, right? But that concept goes out into the real world. Always. Is everybody with me? Everybody cool? Now you should have done a bit of that in grade 9 where your teacher gave you something like this. Put a little, like a X there and a dot there and 3, 5, and 7. And then he or she drew another triangle, put an X there, a dot there, said that was 6, and this was X, and that was Y, and said how long are those sides? You should all have seen that. If you haven't, you should be able to do it in your head right now. The side between the X and the dot was 3. In this one, it's 6. So what's the fraction there? 3 over 6. So this side, 7, is over X. Now you can tell me how long X is, because it has to equal 3 over 6. Right? How long is X? 14. How long is Y? 5 over 10 to make all of them equal a half. All of you remember that? If you haven't seen it, I apologize to you. You should have, but you just saw it proven to you, so now we are okay. Yes? Excellent. Take the last 6 minutes off, and you have no homework for the weekend. Except you have a test on Tuesday. If those of you that remain would be so kind as to do me a favor and put up the chairs of all the lazy folk that left early and couldn't be bothered. Although, to be fair, they know that I hate chairs up when I'm trying to teach, maybe. So maybe they left it on purpose. I'm going to give them the benefit of the doubt.